Okay, so I'm not blaming you, I'm blaming myself for assuming we knew too much on quadratics. So it said a lot of people just did not quite get this. On the quadratics thing, the first day we did, remember this? First day, you got a worksheet. A lot of us got some really bad scores, so we're going to go through it because it's going to be on the quiz. So it says, yep, find the roots. So these are just different examples. Look up here so that you know what you're doing when you go back to that assignment. It says find the roots, then write the roots as a product of two linear factors. A lot of you did not know what this was asking. We've got to get a little bit better at reading the directions in like pieces and figuring out what am I asked to do here. So in the first part it says find the roots. Isn't that asking us to do what? Solve it, right? Find the solution, right? So it's a quadratic, we're solving the quadratic. So look at my first example. You don't need to take notes if you want to just watch, that's fine. X squared plus 64. If I said find the solutions, we would solve it. I would not, this one doesn't factor. Nothing multiplies to be 64 and adds up to be 0. 64 adds up to be 0. Wouldn't that be negative 8 times 8? Is that negative 64? No, so that doesn't factor. We wouldn't solve it by factoring anyways. There's an easier method. Don't we just isolate the square and take the square root? So we would, a lot of people just square rooted it right here. You can't do that. We've got to isolate the square. So we're going to subtract 64 from both sides. So we have x squared is equal to negative 64. What's my next step? Tell me. Square root, both sides of the equation. Root cancels out with power. X is equal to plus and minus what? 8. Negative is I, right? So guys, we just found the roots. We would circle that as our answers. Now the second part says, then write the roots as the product of two linear factors. So you'd say to yourself, product means multiplication. And then remember, we did review, if x equals 8i and x equals negative 8i, then what were the linear factors? Aren't linear factors equal to 0? Subtract 8i, subtract 8i. X minus 8i is equal to 0. Look, degree 1, it's a linear factor, right? Add 8i, add 8i. So we have x plus 8i is a linear factor. There's our linear factors. Now the product of them, before they were split apart, remember, if we were to factor this, which we wouldn't have factored it because there's i's. However, the product of two linear factors, before they were split up, they used to be multiplied together as such, right? Look, isn't that the product of two linear factors? That would be my second answer I circle. Questions on how to do that. So those of you that got it wrong on the quadratics, you'll fix it. So let's look at this next example. It says find the roots, that means solve. So we have x squared minus 48 is equal to 0. Our first step would be to add 48. X squared is equal to 48, right? Square root both sides. Now everybody, I want you to do this. Type it into your calculator. What's the square root of 48? Hurry. Okay, it's a decimal. Let's see if we can change it back to a fraction. Hit the math key on your calculator. Math. Over there on the left, hit math. Hit enter, hit enter. Did it just give you a decimal again? Yes. So that means our calculator can't put it back in a fraction. So it can be written as a fraction. That means it's irrational. Now understand, we don't like decimals as answers. We like the exact solutions. However, if that can simplify, you have to simplify it. We want the simplified answer. So does this break down? 6 times 8. 6 breaks down into 3 times 2. 8 breaks down into 2 times 4. And 4 breaks down into 2 times 2, right? We pull out a 2, we pull out a 2. So x is equal to plus and minus 4 square roots of 3. Now guess what? On your worksheet it was square root of 8. Can that simplify? Yes, so I marked it wrong if you just wrote the square root of 8 on the worksheet. So then writing it as a product of two linear factors, we have x is equal to 4 square roots of 3. We have x is equal to negative 4 square roots of 3. Linear factors are equal to 0, so minus 4 square roots of 3. So we're going to have x minus 4 square roots of 3 as one of our linear factors, right? Equals 0. Right here, what do we add? 4 square roots of 3. So x plus 4 square roots of 3. There's our second answer. The product of two linear, they're degree 1. The product of two linear factors. So we have that and that as our answers for this. So on the quiz, are we going to do a little bit better this time? Next time. Okay? Do you want me to do x squared plus 2? Are we good? You're feeling good with these? If so, say yes and we'll move on. If not, I would love to do another one. How are you feeling about these, class? If you want to do another, raise your hand. Couple? Okay, so maybe we should. Okay, I want you to try it. Go. Do this one. Go. On your whiteboard. All right, it's good. It's good to make mistakes because then we learn. So we know we set it equal to 0, right? A lot of you totally got this. Next, subtract 2. Most of you got this far. X squared is equal to -2. Square root it, right? Most of you got that far, right? X is equal to plus and minus the square root of -2, which we can factor out, or pull that out, not factor it out. Sorry, we're pulling that out, right? Square root of a negative is I. So we have x is equal to plus and minus, the I comes in front, I square roots of 2. Then I saw people forget the square root of 2 on accident. So now we write that as the product of two linear factors. So look, let's think advancedly for a minute. If we have x is equal to positive I squared root of 2, why don't we subtract I squared root of 2? Yeah. If we have x is equal to negative I squared root of 2, when we add I squared root of 2? X plus I squared root of 2. So that was a good one to do. Good job. Everybody, you did awesome. Here we go. Okay, next thing I saw that you struggled with on quadratics was this. Given the zeros, write the quadratic in standard form. So remember, guys, if this is where it's crossing the x-axis, if these are the solutions, then remember, we can go backwards to find the quadratic. If these were the solutions, weren't our linear factors x plus 1 equals 0? Right? That had to be the linear factor if that was the solution. That's going to help you with today's lesson. We're going to be doing more of that, but with more advanced stuff. Right here, subtract 3. So wasn't x minus 3 equal to 0 another linear factor? Before they were split apart, we had x plus 1 times x minus 3. Then you double distribute, combine like terms. I'm not going to do that. Questions? So question for you. X equals -3i is a solution. Quadratics always have two solutions. Degree 2 solutions. What's my other root? Positive 3i. Conjugate pairs happen with imaginary solutions and irrational solutions. So we would add 3i. If we're going backwards, subtract 3i. So we would have x plus 3i is equal to 0. Isn't that the linear factor if that was our solution? We'd have x minus 3i is equal to 0. That was our linear factor if that was our solution. Now, a lot of you multiplied this wrong, so I want to do this one quickly, though. So pay attention and ask if I am not making sense. We have an x squared minus 3ix's plus 3ix's. Careful, this is where people messed it up. Minus 9i squared. 3 times -3 is -9. I times I is I squared. Middle terms cancel out with conjugates, and they did. We have x squared minus 9i squared. So isn't that x squared minus 9 times -1? I squared is -1, so we have x squared plus 9. That's the quadratic. Well, it makes sense. Look, if you went backwards and solved it, wouldn't you end up with these solutions? Do you see how you can check your answers? We're all golden. If x equals the square root of 3, then x equals what? Is that an irrational root? You better check. Type it in your calculator, math enter, won't change it back to a fraction. So its conjugate must also be a root, right? Do you want me to continue this one, or are we feeling good? You're sure you're feeling good? Absolutely, everybody? So we would get x squared. Can anyone tell me what it would be? Minus 3, right? Okay. We could go through the math, though, and do it, right? Okay. Sweet. Okay, so I'm going to let you, for this quadratic, some of you got like a 4. If you did, then I'm going to let you, anyone, if you didn't get a 10, I'll let you redo it this time. You can redo those problems. You don't have to redo the whole thing. Redo those problems on a separate sheet of paper, staple it to it, rehand it in. Does that sound like a fair deal? I'm being pretty fair because I want you to fix them. Okay, awesome. That'll be due next time. Let's get to what we're doing today. So today, make sure you pay close attention and ask questions, okay? Because there's a lot to today, but it's not super hard, but I'm going to try to make it make complete sense to you. So it's just building on what we already know, which is really good. So 2-3 is called polynomials, linear factors and zeros. We already know what linear factors are because of quadratics. and we know what zeros are, where it's crossing the x-axis. So first of all, if we have a polynomial, then finding the zeros of a polynomial function will help you factor the polynomial. If we know the zeros, don't we know the linear factors? Yep. Also, it'll help you graph the function and solve the related polynomial equations. Isn't where it crosses the x-axis the solution? Okay? So if we have x equals -5 and x equals -3, we could work backwards, we could know the linear factors, and we could use those to graph. If I gave you this not factored, wouldn't we factor it and then set those linear factors equal to 0? Right? Okay, so that goes true for all polynomials. So now we're not going to only be dealing with quadratics. We're going to be dealing with higher than quadratics, but the idea is the same. The rules are the same. So it says the following are equivalent statements about a real number b and a polynomial. So if we have a polynomial of any degree, that's basically what that's saying there. We have a polynomial of any degree, then x minus b is a linear factor of the polynomial. So why is it linear? Because isn't x minus b x to the first? Okay? B, if that's true, if x minus b is a linear factor, then b will be a 0 when we set our linear factor equal to 0 and solve. So b would be a 0, which is also called a root, right? Or solution. And b is also an x-intercept. So does everybody understand what I'm saying here? We have linear factors, we have the zeros, we have the solutions, we have the x-intercepts, and voila. We're all good? Okay, let's look at my first example. Just look. I don't need you to write it down. If you want to write it down, you could go back and rewatch the video, but I bet it will just make sense. So it says, write the polynomial in factored form. So you've got to say to yourself, what kind of factoring am I dealing with? Because there's a lot of different types we're dealing with in secondary 3. We have 3 terms, but it is not quadratic. We don't do right now what multiplies to be a times c and adds up to be b. That's a quadratic method. So you'd say to yourself, well, how the heck am I going to factor this? We have 3 terms. Is there something in common? X, right? So let's factor out the greatest common factor. So I'm going to factor out an x. So let's go divide each term by x to see what we have left inside our parentheses. So we have an x squared minus 2x minus 15. Now look, we have one linear factor. Isn't that degree 1? X to the first? So there's one linear factor. Cool. Well, we need them all to be linear factors, or we hope they can all be linear factors. So let's look inside our parentheses, ignore x. Now isn't it quadratic? Let's see if it factors, because we know how to factor quadratics down to its linear factors. So do you see I'm just factoring again? So I'm going to ignore x completely for a minute. I'm going to look for what multiplies to be negative 15. That is a times c and adds up to be b, which is negative 2. 5 times 3, negative 5, right? Yeah. Now carefully look. Is my a value positive 1? Yes. So we could drop and break. That always works. However, if your a value is positive 1, we can quickly factor this. So this is going to factor to be x minus 5 times x plus 3. So guys, the final answer was x times x minus 5 times x plus 3. Now here's how we know we are done. Linear factor, linear factor, linear factor. Yay, we factored this down to linear factors, and we're done, right? It asks us to factor. So now let's say I added on to that and said, well, find the solution. Why do we like linear factors? Because then can't we just set those equal to 0 and solve it? So it's pretty easy from here. We have x is equal to 0, that linear factor equal to 0, x minus 5 is equal to 0, and x plus 3 equals 0. We love linear factors because we can do this. Solve for x, done. Add 5, done. Subtract 3, done. So our solutions are those 3 values. Everybody comfortable? However, this did just say factor, so we do need to know the difference. It said factor, so our final answer would have been here. I just went further to make a point. Does that make sense? Let's do another one quickly. What is the, you go, you do it, go for it. What is the factored form? On your whiteboard. That's okay, we're getting there close. All right, so we say to ourselves, okay, what's the factored form? What kind of factoring are we dealing with? There's an x in common. I'm going to factor out x. Left is x squared minus x minus 12. We have one linear factor. We want them all to be linear factors, so we'll factor this again. We'll multiply to be negative 12 and adds up to be negative 1. 4 times 3, negative 4, positive 3. We can quick factor this because this is a 1. So x minus 4 times x plus 3. So we would say x times x minus 4 times x plus 3. The reason we know we're done is they're all linear factors. We're done. That's it. There's our answer. Then I said, okay, now tell me, what are the solutions? So set each of those equal to 0. So we have x equals 0, we have x equals 4, and x equals negative 3, right? Everybody? That's where it's going to be crossing the x-axis. Awesome. All right, so look up here. Last thing on the finding the zeros. So it says find the zeros of each function and state the multiplicity of multiple zeros. So I'm going to pause on that. Think back to a quadratic. Let's say that was crossing at 3, or touching down at 3. This is when we have a parabola come down, touch the x-axis, and bounce back up. That's when we have x minus 3 times x minus 3. Didn't we get x equals 3 and x equals 3 technically twice? Technically, yeah, we did, right? But it touched the x-axis once and bounced back up. So that was x equals 3 with a multiplicity of 2, because it happened twice. Does that make sense? Okay, so look right here. We have y equals x plus 2 times x plus 1 squared times x minus 3. What we're looking at is x plus 2 times x minus 1. Squared means x minus 1 again, right? And x minus 3. So what are the zeros? X equals negative 2, x equals 1, and x equals 3. So we would write it in secondary math 3. X equals negative 2. It also equals 3. And it equals 1 with a multiplicity. Yep. I can't talk and.
Multiplicity.
Oh, well, of 2. Okay, here we go. Does everybody understand that? I spelled that word. Okay, let's continue. Let's not dwell on it too much. Here we go. All right, so number 2, it says find the zeros. Well, this one was already factored. Number 1 was, but this one's not. Now look at it. Not quadratic, nothing, no greatest common factor. Does anyone remember how we would factor something with 4 terms? Grouping. Good. There we go. Sorry. Grouping. Very good. We factor by grouping. So you group the first 2 terms, group the second 2 terms. Go for it. Go for it on your whiteboard. Go for it. You tell me what the zeros are. Factor by grouping. This one's going to take a few little steps. Let's test how good you are. Just because we don't have too much time here. So we factor by grouping. I still think some of you aren't quite there on factoring. Pay very close attention. Greatest thing in common here is an x squared, right?
Yeah.
So we divide each term by x squared. Left is x minus 3, right? Yeah. I'm still seeing some people write this a little bit not so good, and I think that's why you're confused. What's in common here? Negative 4. We factor out a negative because there's a negative in front. Factor out negative 4, and left is x minus 3. Now, a lot of you are not thinking correctly about this, so I'm going to state this very slowly one more time. We have 2 terms here. We factor out greatest common factor of each term. What's in common? X minus 3. So we're factoring out x minus 3. There's only one of those. So divide each term by x minus 3 to see what's left. In the first term, what's left? What's left in the second term? Minus 4. Now look, one linear factor. Is this a linear factor? No, but don't we know how to factor quadratics? So, go for it. Well, I hope. All right, so we do what multiplies to be negative 4 and adds up to be 0, 2 times negative 2, right? We can quick factor it, so this factors to be x minus 2 times x plus 2. So we have x minus 3 times x minus 2 times x plus 2, right? So we have x is equal to, now they're all linear, x equals positive 3, x equals positive 2, right? And x equals negative 2. Those are the zeros. No multiplicity there. Okay, now look at number 3, because if I gave you a graph, I would expect it to be really easy for you to tell me this, the zero. So, first of all, we have a 0 at x equals 3. We have one at x equals 2, and then we have another one right here. X equals negative 2. Well, that's only 3. Isn't this an even degree? Not quadratic, it must be degree 4. There must be 4 roots. Where are we missing one? Perfect. Why? It bounces. So isn't that touching down at negative 2, bouncing back up? Technically touching negative 2 twice. So we'd say x equals negative 2 with a multiplicity mult of 2. That's fine. Questions? Do you see that? Okay. Alrighty. So looking at this one, x equals what? It's already factored for us. And do we have questions on that? Okay. Last one before I let you work. Here we go. So it says, now pay attention, this was the hardest part for people because they kind of vaguely paid attention and then they kept asking, wait, now why did you do that again? I'm like, just pay attention, it's fine that you asked, but I really did go over it so many times. Find the zeros of the function, then graph it. So looking at this one, it's not factored. To find the zeros, we want to factor it. So won't we factor out an x? Left is 2x squared plus x minus 1, correct? Now we factor this even further because it's quadratic. What multiplies to be, I'm going to go over here, negative 2 and adds up to be positive 1. 1 times 2, negative 1, right? Uh-oh, careful though. Can you quick factor it? No, right? Look, a value 2. So we drop and break. We drop down 2x squared. We drop down negative 1. We rewrite positive 1x as those two factors, right? 1x, negative 1x plus 2x, right? Minus 1x plus 2x. Then now there's 4 terms. That's when we factor by grouping. Group those two, group those two. And common here is an x. So left is 2x minus 1, correct? In common here, don't say nothing. There's always a 1 in common, right? Left is 2x minus 1. Now look what's in common, 2x minus 1. So we factor that out, thus it divides out, leaving us with x plus 1, and then we can't forget that there was an x to begin with, right? So x equals 0, x equals negative 1, and x equals, you'd add 1, divide by 2. 1/2. So guys, that's where it's crossing the x-axis at 0, at negative 1, and positive 1/2. Okay, now here's this is where it gets harder for people. We need to draw in the rest of this function, but we need to be a little bit careful here because we need to draw as correctly as possible. So I'm going to ask you, next step is what's my end behavior? Odd, right? Odd and positive. So won't odd be opposite end behavior? And positive would be like a positive line. Okay, so I'm going to go ahead and draw it down and up. And now I need to figure out what my function's doing in all of this, right? So what you're going to do is say, well, let's think about this. If I want to know what's my function at some value over here, then won't I just plug in that value into your function and it will give you how high up to go, right? That's how functions work. You put something in, you get something out. So I'm going to plug in a value on x that's between these two zeros. So what's between negative 1 and 0? Negative 1/2. So I'm going to make a chart, an xy chart here. So I'm going to plug in negative 1/2. Now we have to plug it in correctly. So if we figure out where a function is at, negative 1/2 will be there. So everybody type this in. You all need to practice typing it in because first hour I didn't talk about it and then everybody got it wrong and I talked about it the next time. I always learn from the first hour. So if we plug in negative 1/2, we have to use parentheses. So type it in like this. 2 times negative 1/2 raised to the third plus negative 1/2 squared minus negative 1/2. Just type it in. Like anytime we plug something in or substitute something in, you use parentheses. Tell me what you get out. You should do it. I put the answer there. That's not the point, though. It's making sure we can type it in. You get a half? Okay. So we know, guys, so we're going to keep graphing here. We know at negative a half, we know that at negative a half, our function is up a half. Okay? So we know it comes like that. Does everybody understand? You mean typed it in wrong? Use parentheses as such, and you should be okay. Okay, now, pay attention. Between those two zeros, we need to know how far down. Maybe it's clear down here. Maybe it's clear down. We don't know. Let's figure it out. What's between 0 and a half? A fourth. So let's plug in 1/4. So you'll do this again. 2 times a fourth cubed plus a fourth squared minus a fourth. What's my function out of fourth? The reason we just can't use our table of values is because that only works in whole numbers. Somebody asked me that for salad. So how far down are we going here? A half? It's between 0 and a half. You're right, that's our zeros. It's hard to see on this graph. That's actually a half. Does that make sense? Yeah. Oh, did I? Sorry. A half and 0. So that's why we're plugging in a fourth. I'm so sorry. Did you get 0.5 something? Yeah. Negative 0.5 something. So we're going over a fourth, over a fourth and down about a half, right? I'm sorry, 0.15? So we're barely going down. Does everybody see how that works? Very tiny, very barely going under. Okay, one more. Here we go, one more quickly. So we have x equals to what? We're graphing it, we need the zeros. X equals -1 with a multiplicity of 2, right? And we have x is equal to 1. Okay, let's graph that. So we go -1. It's over 1 and over 2. Okay, now let's start in our end behavior. Now look, there's 2 x's, 1x and 1x. We only need to look at the leading coefficient, right? For end behavior. 2 x's times x will be x to the 4th. So it's even, and aren't those all positive in front? So it's going to be up and up. Now let's figure out what's going on in between. So let's think about this. First of all, if we have x equals -1 with a multiplicity of 2, won't it bounce back up? Oh, but I need to not go too far. So let's now figure out where we are exactly between -1 and 1. Let's plug in 0. So I'm going to make an XY chart. Let's plug in 0. Just type it in exactly as you see it. So 0 there, 0 there, 0 there. What is my Y value? I think we get +2. Okay, so we are +2, so that means we're coming down here. Now let's find a point between 1 and 2, those zeros. Between 1 and 2, because maybe I'm clear down here, maybe I'm right there, maybe I'm right there. So what's between 1 and 2? 1.5, right? So once again, you'll plug in 1.5, 1.5, 1.5. So what's my function at 1.5? -1.5, okay, 6-ish. Yep, so we're going over 1.5, down 1.5. Did everybody else get -1.5? Okay, sweet, so we're kind of down here, right? Ding, ding. Do you see how I drew it in? We're all comfortable? Okay, I'm going to do number 6 with you, and then the rest, and then I'll give you like 15 minutes to practice this, okay? So let's do number 6 together off your worksheet to make your homework load way wider. Here we go. It says, write a polynomial function in standard form with the given zeros. So just a minute ago, we were given the polynomial and finding the zeros. Now we're given the zeros, find the polynomial. So don't we work backwards? Add 1, right? Linear factors, we need the linear factors. So we have an x plus 1. Now are we going to have x equals -2? Wouldn't we add 2? So we're going to have an x plus 2. Same here. Are we going to add 3? So we'll have x plus 3. Do you see how I'm going backwards? If not, say no, I don't actually. You got to be honest with me because I'm going to take your word for it. We have x equals -4. What do we add 4? So we have x plus 4. So these are our linear factors if those are our zeros. Now take my advice. If you ever are multiplying 4 things together, multiply 2 of them together, multiply the other 2 together, and then multiply the others. So let's go through this quickly. We have an x squared, right? Plus 2x, plus x, plus 2, combine like terms, x squared, plus 3x plus 2, correct? X squared, plus 4x's, plus 3x's, plus 7. So we're multiplying x squared plus 7x plus 12, right? Not 7? I saw a lot of us do that on the other worksheets you want to do. We got to be careful. We don't get going too fast. 3 times 4 is 12, plus 12. Now we will triple distribute very, very carefully. So this to here, this to here, this to here, right? Okay, go for it. I'm going to let you go for it. Show me your answers when you're done. If you do it on the whiteboard, that's great. Then you've got to show me before, because I'm going to stop giving credit for the people that are handing their stuff in without work. That's fine. Do it on your whiteboard. Yes, please do. And then show me, and then I'll check it off for you. So we have triple distribution going on in here. So tell me what answer you get. Be careful. One little error can just be so tragic, because then you have to go back and figure out where, and it's hard. Okay. Show your work. Okay, so once again, guys, if you're not simplifying it this way by multiplying 2 together, then multiplying the other 2 together, and then multiplying, that's where you're missing stuff. It's easy to miss stuff by trying to think about going through it. Okay, so we should have got, if we've done it correctly, you should get x to the 4th. Don't just write down the answer. Actually, I'm not going to do that. Well, sure, you'll just get the answer from each other. Make sure if you get it wrong to go redo it and figure out where you went wrong, because that's what's important. Not getting the right answer, I give you the answers if you want them. Plus 50x's plus 24. So if you didn't get that, figure out where you went wrong. Great. So we've already actually done this, because remember on the day when we learned turning points, okay? And then I said, oh, let's use our calculator to find out those exact places of those turning points. Well, those are considered relative mins and relative maxes. Now, here's why it's not an actual minimum and an actual max. Isn't this function going upward forever? Yeah. Technically, there's no max value then. It's going down forever, so technically there's no minimum value, but in general, in the picture, this is the relative min and the relative max. Okay, does everybody get what I'm saying? Yeah. We have turning points, so there is a relative min and a relative max. Just one thing to note, and I haven't even said this to my other classes, but if we had, for example, instead of this, if this came back up, there would be 2 relative mins. Does that make sense, everybody? Yeah. We just use our calculator to find these. Remember, we do second trace, and then if we want to find the minimum, we'll hit min, and you'll do a left bound, a right bound, right? Yeah. Enter, enter, it'll give you that XY point. If I wanted, then I'd do second trace, max. I'd go left bound, scroll over, right bound, enter, enter. It'll give us a point for max. Okay, so let's do a problem off the worksheet. Number 25 and 27, I'm going to do with you. I want you to cross out and the zeros of each function. We're just going to practice with those, finding the relative max and min. So it's just calculator. Everybody go, just start. Type in 25 into your calculator. Let's find the relative max and the relative min. So type that into your calculator. Okay, we should be about there. So this is what your graph kind of looks like. So here's our max, right? What was our max at? Tell me 2 decimal places. You got, what was it? 2.5. I don't think I got that when I did it. Maybe I did. Did everybody else get that? Maybe it is 2 point. I think I got something different though. For max. Make sure your left bound and right bounds are correct. It is? Okay. I swear we didn't get that last hour. It's so weird. Okay. Okay, so it is. That's just weird because I got 2.53. I thought you were saying 2.5 comma 3. Sorry. So our max is, you're right, 2.53 comma 6.5. Gotcha. Sorry about that. 6.51. There's our max, right? And our min, what'd you get? This is what's really weird. If anyone can figure this out, I'll give you brownie points because the first time I did it, I got 10.5. Well, on my paper, I wrote down 10.5. Oh, here's why. It depends which problem you're doing. This is why. If you're going off my board, then it's going to be this. I wrote it wrong. I'll accept either answer, okay? I'll accept either answer because it's just different functions. Okay. So sorry about that. We have different functions. So if you did this one, what'd you get? So sorry about that. I'll accept either because I messed that up. You see what I'm saying? 76 is not what your paper is. It's 72. Okay. All right. And the min was at, what was the min of this one? Did anyone do it? 5.13 comma negative 11 point something. Okay. All right. And number 27. If you graph 27, let's all do, so we have our, you'd say max, relative max, that's our max, and relative min, you'd say min. All right, so I will accept either your answer if you did it from the paper or my answer. That's acceptable because I messed that up. Yes? No. So looking at 27, it says, okay, so let's find the max and min. If you graph it, let's see what it looks like, everybody. So it's like one of those ski-wampus looking, not parabolas, it's not a parabola, but a ski-wampus parabola, right? Isn't that a degree 4 usually, or degree, it is degree 4, but doesn't that happen? Okay, so now doesn't this one only have a min, relative min? So you'll do second trace min, and then you tell me what it is, and you get negative 0.99 comma negative 1. Negative 0.99, doesn't that round to be negative 1? So we get negative 1, and that's our min, no max. Questions on that? Okay, are we all golden? Yes. Paper. Okay, so guys, it's all good and dandy, it's all fine and dandy now that we understand how to do it, but you have to actually be able to apply it. So I really need you to look up here. It's all fine and dandy if you can do the math, but if you can't apply it, then you don't understand it. So we're gonna do 24 together so you have less homework. There we go. Now guys, pay attention. Don't just say I'm gonna keep working and write down your answer. You won't be able to do the rest of the story problems if not. So we have to be able to apply it, and I'm gonna make sense to you of what we're doing here, okay? So let's read number 24 on your paper. It says the volume in cubic feet of a CD holder can be expressed as volume of X is equal to negative X cubed minus X squared plus 6X. Or when factored as a product of its 3 dimensions. So we know volume is length times width times height, right? Okay. It says the depth is expressed as 2 minus x. So depth is, they're considering depth. So it says depth is expressed as 2 minus x. Assume that the height is greater than the width. So they're calling the length the depth. So instead of length, they're calling length depth. They're telling us that length is written as 2 minus x. That's the linear factor for depth. All right, so it says that height is greater than width. So our height is greater than our width. So let's answer A. It says factor the polynomial to find the linear expressions for the height and width. So if we know depth, we need to know height and width. So let's factor it. Look back at the beginning. We have negative x cubed minus x squared plus 6x. So let's factor out a negative x, right? If there's a negative in front. So we'll factor out negative x divided by negative x. Guys, please pay attention to this. Otherwise, this isn't going to make sense. And then you can't do the rest of the story problem. So we're going to get x squared plus x minus 6, right? So let's continue to factor the inside here. We're looking for what multiplies to be -6, adds up to be 1, 3 times 2, -2, +3, right? Quick factorable, so we can factor this to be x plus 3 times x minus 2. So I'm going to rewrite that right here. So we have volume is equal to, right now we have it as -x times x plus 3 times x minus 2. Now look, do any of those look like that? Kinda. This, except for that is actually very different than that. So let's see what we have here. Let's reorder this. We got to reorder it correctly, right? So let's put this 2 in front since they've written it in front. So that's -2 plus x. Now looking at that, isn't there a negative in front? That's when we factor out a -1. So then left is 2 minus x, correct? Oh, that's where they get the depth from. So right now, pay attention to this. We have this, 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 and this. Those are all factors, right? Yeah. So we can reorder it. We have -1 times -x times x plus 3 times 2 minus x. You see how I just reordered it? -1 times -x is +x. We have x times x plus 3 times 2 minus x. So do you see how it took some manipulation to figure out exactly where they got that from? So now we say, okay, there's the dimensions for volume. There's our depth. Here's our length and height, or sorry, our height and width, and it said the height's greater than the width. So we would answer it as, on A, we would say, well, if our height is greater than our width, isn't plus 3, x plus 3 greater than that? So we'd say height is x plus 3, and width is x. Do you see how I did it? It did take some thinking on a kind of advanced level. We had to take and manipulate that x minus 2 to be more what we wanted. Let's answer B. It says graph the function, find the x-intercepts. Well, don't we already know the x-intercepts are going to be, these are the factors, right? Yeah. So isn't it, the x-intercepts are going to be x equals 0, right? -3 and, hey, graph it on your graphing calculator. Just to get an idea here. And you can type it in either like this or in the factored form, it doesn't matter. Okay, if you graph it, it looks like, and it's going to cross obviously at -3, 0, and 2. It looks like this. Okay, we graphed it. It says, graph the function, find the x-intercepts, what do they represent? So I'm going to explain something, guys. This is the function that models volume, okay? So at this value, our volume's here. At this value, our volume's here. Does everybody understand that? So isn't this where it's crossing the x-axis where our volume is equal to 0? Yeah, so volume is equal to 0 are what those mean. So let's answer C. And I want to explain it to you. It says, now look at your paper, because I want to have this up high so everyone can see. So what it's asking us is, it says, what's a realistic domain, which means what we can put into our function, what's a realistic domain for this? Let's think about it in the real world, guys. If we're dealing with volume, are we filling something up? Putting something in. Can you fill something up with something negative? So we throw out all those negative x values, right? Throwing those out. Now think about it in the real world. If we're plugging in something, we put something in, and it's filling up, will it ever come out negative as an output? So can't we throw away, even though these x's are positive, aren't they getting negative outputs? So our realistic domain is between x equals 0 to x equals 2. Because that's really the only place we're putting something in and getting something out positive. So does that make sense to you? So we'd say from C, on C you'd say from 0 to 2. Okay, now let's answer the last one. What does it say? Oh, what's the max volume? Well, don't we just find the max? Isn't that where our volume's at its maximum amount? Yep. So you'll do second trace, find the max. And we want how much volume, not where is our volume the greatest, it's how much is the greatest volume. So we want the y value. So you get 4.06. 4.06, and remember a volume is a length times a width times a height. You're multiplying a foot times a foot times a foot. So that's feet cubed, cubic feet. Okay, good. So hopefully that makes sense. So in the future, if I give you a function and I say, this function models, let's say cells over whatever. What is the maximum cells that you're going to have? When you just find the max, graph it, find the max. Okay. Last one, then the rest of the time will be yours. Here we go, 21. 21, let's do it together. Because some of us need this. So let's think through this together so that I can show you how you should. I was going to say that can't be done. Okay, so it says a storage company. Now this is like a real world problem. If any of you go on to be engineers, you could run into something like this. Your company could come to you and say, I need you to solve a problem for me. This is a very good example. So it says, a storage company needs to design a new storage box. There's our original storage box that has twice the volume of its largest box. Okay, interesting. The largest box right now is 5 feet by 4 feet by 3 feet. Okay, so 4 feet by 5 feet by 3 feet, whatever. It doesn't matter where those go. Okay? Now, looking at, so it says the new box must be formed by increasing each dimension by the same amount. So we're going to get this new box. We need to increase those by the same amount. So when we just add x, add x. So 5 plus x, 4 plus x, and 3 plus x. Okay. Now it says the new box. The new box must be formed by increasing each dimension by the same amount. We've done that. Find the increase in each dimension. So I'd say to myself, well, what's my original volume? Length times width times height. 5 times 4 times 3 is 60. They want, now this is what your employer would say, I need double the amount of volume available in here. So you'd say, okay, I can do that. So double the volume is, so this volume needs to be 120. Interesting. So let's see how much we need to increase it by. Let's set up a true statement. When does our volume equal? Well, volume is length times width times height, right? Yeah. So 5 plus x times 4 plus x times 3 plus x. Now, aren't we just finding the x that will make this a true statement? So it's solving it, right? Let's solve by graphing. Way easier. In the real world, you solve by using a calculator. So let's graph it. Now, understand. Solving by graphing means when does this function equal this function? So get your graphing calculator. Hit y equals. In y1, type in 120. In y2, type in that function. They're two different functions. We want to know when they are equal. Now here's the next thing. If we had a straight line at 120, we need our windows y max to be at least to 120. Let's make it higher. So go to window when you've got that typed in, and y max on your window, let's put it at like 150 so that we can see as high up as 150. So we have this straight line at 120, then you'll hit graph, and you have a cubic, and I don't know exactly what the cubic looks like this. Yes. You could totally use the table too. Yep, absolutely. So you just find one, yeah, you could go to the table. So I'm going to just keep going since we're this far. So now are we finding where they intersect? So you'll hit second trace, go to intersect, hit enter, and it says first curve, it's on the line, hit enter. Second curve, it's on the cubic, hit enter again. So you're just hitting enter 3 times after that. So what x value, where do they intersect? X equals 1. So guess what? We had to increase each of these by 1. X equals 1. Do you see how we solved by graphing? Okay, so x equals 1. So we solved it. So it says, how can you write the dimensions of the new storage box? We already did that. So x equals 1. So we're increasing by 1 foot. So then it says, what are the new dimensions of the storage box? So wouldn't that be 4 by 5 by 6? So that's like a real world, I'm an engineer in the real world, and that is something that you very validly could see, I would say. So x equals, sorry, we already said that x equals 1, so our new dimensions are 4 by 5 by 6. Right? You plugged in 1, guys? Do you see that? Yeah. Sweet! The rest of the time is yours to ask for help, whatnot. Number 22 is for advanced thinkers, so it is not a requirement. However, we do have some advanced thinkers in here, so do it. The rest is homework. You have time in class to work, so.